When determining conductor ampacity, several factors must be considered, including the ambient temperature and the temperature rating of the terminations. According to the National Electrical Code, specifically Section 310.15b2, the ampacity of conductors in a raceway must be adjusted for both the number of conductors within the raceway and the ambient temperature surrounding the raceway. The ambient temperature is the temperature of the air immediately outside the raceway. This temperature plays a crucial role in determining the allowable ampacity of the conductors. Furthermore, Section 310.15b2 of the NEC states that the ampacity of conductors must also be adjusted based on the temperature rating of the terminations. Terminations, in this context, refer to the points where the conductors connect to equipment, such as circuit breakers, transformers, or other electrical devices. These terminations have a specific temperature rating, typically 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius, indicating the maximum temperature they can safely withstand during operation. In the scenario presented, the conductors within the conduit are rated for both 75 degrees Celsius and 90 degrees Celsius. However, the terminations are rated for 75 degrees Celsius and are located in a high ambient temperature area. Therefore, the maximum ampacity of the conductors must be derated based on the 75 degrees Celsius column. This is because the terminations are the weakest link in the circuit. Even though the conductors themselves might be able to handle high temperatures, the terminations cannot. If the terminations are exposed to temperatures exceeding their rating, it can lead to overheating, insulation breakdown, and potentially a fire hazard. To accurately determine the allowable ampacity, firstly consult the appropriate ampacity table in the NEC, specifically Table 310.16. This table provides the ampacity of insulated conductors rated up to 2000 volts, based on conductor size and insulation type. Secondly, identify the base ampacity from Table 310.16 using the 90 degrees Celsius column for the conductor, since it is rated for both 75 degrees Celsius and 90 degrees Celsius. However, keep in mind that this value is only a starting point. Thirdly, apply the ambient temperature correction factors. The NEC provides correction factors for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, you must multiply the base ampacity by the appropriate correction factor from the table. Fourthly, apply the adjustment factors for the number of conductors in the raceway. When multiple current-carrying conductors are bundled together in a raceway or cable, the heat generated by each conductor can raise the overall temperature within the raceway. To account for this, the NEC requires that the ampacity of the conductors be reduced based on the number of current-carrying conductors. Use Table 310.15 cone to determine the appropriate adjustment factor. Multiply the base ampacity by this adjustment factor. Fifthly, compare the derated ampacity with the termination temperature limitation. After applying the ambient temperature and number of conductors adjustment factors, compare the resulting ampacity with the temperature rating of the terminations. In this case, the terminations are rated for 75 degrees Celsius. This means that the conductor ampacity cannot exceed the ampacity listed in the 75 degrees Celsius column of Table 310.16. Even if the derated ampacity is higher. Sixthly, select the lowest ampacity value. Final allowable ampacity for the conductors is the lowest value obtained after considering all the derating factors and the termination temperature limitation. This ensures that all components of the circuit operate within their safe temperature limits. To illustrate with an example, consider a situation where you have 3 number 12 American wire gauge or AUG THHN conductors in a conduit in an ambient temperature of 40 degrees Celsius. The terminations are rated for 75 degrees Celsius. Firstly, from Table 310.16, the base ampacity of a number 12 AWG THHN conductor is 30 amps, based on the 90 degrees Celsius column. Secondly, since there are 3 current-carrying conductors in the raceway, the adjustment factor from Table 310.15 cone is 0.80. Therefore, the ampacity is reduced to 30 amps multiplied by 0.80, which equals 24 amps. Thirdly, since the ambient temperature is 40 degrees Celsius, which is above 30 degrees Celsius, an ambient temperature correction factor needs to be applied. From the ambient temperature correction factor table, the correction factor for THHN conductors at 40 degrees Celsius is 0.91. Therefore, the ampacity is further reduced to 24 amps multiplied by 0.91, which equals 21.84 amps. Fourthly, since the terminations are rated for 75 degrees Celsius, the final ampacity cannot exceed the ampacity listed in the 75 degrees Celsius column of table 310.16. For a number 12 AWG conductor, the ampacity in the 75 degrees Celsius column is 25 amps. Fifthly, comparing the derated ampacity of 21.84 amps with the termination limit of 25 amps, the low value is 21.84 amps. Therefore, the final allowable ampacity for the number 12 AWG THHN conductors in the scenario is 21.84 amps. In summary, when derating conductors for ambient temperature and number of conductors in a raceway, it is crucial to also consider the temperature rating of the terminations. The terminations are often the limiting factor in determining the overall ampacity of the circuit. Always use the lowest ampacity value obtained after applying all derating factors and considering the termination temperature limitation to ensure a safe and reliable electrical installation. The person who is not accounting for the derating factor for the terminations is incorrect, as this could lead to unsafe operating conditions and potential equipment failure. Proper application of NEC guidelines is essential for ensuring electrical safety and code compliance. It's also very important to consult with the local electrical inspector to ensure compliance to the electrical code.